Okay, so let's make our simulation now. Drop down a dot network here. We'll call this, there's going to be several simulations here. We'll call this Liquid Sim. Seems aptly named. And while we're here, I'm going to press C to bring up my color palette. I like to make the helper geometry green and the simulation geometry purple. Don't ask why. While we're also here, let's set up a little central control panel area. I'm going to call this controls. I like this to be, here's the little shape window here. I like to make that a circle, and that can be black. So what is control panel? We do this in some lessons. This is kind of just be like a collection of central settings that we can always find in one spot. So go to, on that null, go to parameter and channels and go to edit parameter interface. Drag a folder right up to the top. We'll call that controls as well. And the first control we're going to want is really the first two. Spoilers. Let's just do them both at once. These are going to be for the voxel size, the particle separation size, and the voxel size of our simulation. So the first one can be particle separation. Call that part sep or something. And the other one is going to be more of a convenience thing for us. This is not something we're going to set ourselves manually, but it's just going to do one quick calculation for us. So there we go. So now, and this is the kind of thing that I can leave open over here now, particle separation, voxel size. So let's set up the stuff that will actually care about that. First up, we need a flip solver, because that's what we're doing. We're going to need a flip object. That's going to store the various pressure fields, the particles, the velocity fields, the collision fields, all the data that the flip solver needs to crunch. We're going to want a gravity force, like so. And just thinking ahead, because we're going to need colliders later on, I'm going to put this merge here and say that that's going to be a collide relationship and anything that's plugged into it. So set that to mutual. And there we go. Press L to organize. And there you go. We have, technically, a fluid simulation. Press play, and it falls, and that's wonderful. First thing you always got to do is in the flip object, under the guides, particles, turn sprites off. Why is that the default? I don't know. Nobody wants that. The sprites are literal images of spheres, and there's many of them. And when we have millions of points later, we don't want the GPU to waste its time putting an entire image of a sphere on a million particles. So just particles is fine. The next thing we need to do is change the bounding of our sim. Now internally, Flip actually isn't going to do all of this. Flip is going to kind of resize itself to just around the particles themselves, but this is technically the maximum allowable area. So the problem with having a huge area, like why not just leave it be huge all the time and not worry about it? Because when we have our particle separation and therefore the voxel size of our sim, because the voxel size, as you might recall from the first lesson, Liquids 1, well, it's not showing up because I'm in recording mode, but the tooltip text on your computer should say that the actual voxel size of the simulation is the particle separation times the grid scale. So the point is, if your liquid sim is taking place here in the riverbed, but some crazy splash sends a bunch of particles all the way up here to this far corner, it now has to resize the simulation to include all of that, and it will be at the voxel size that we mentioned. So all of a sudden your RAM's going to spike, and just don't do it. So on the flip solver, go to volume motion. You can click on this, the manipulator here, if you want to shape it yourself. We can at least rough it in this way. We already know, I suppose, that our ground is 10 units long. So you could just put 10 here. 10, we'll make it like 1.5 meters high. We know that we made it 3 meters wide before when we were setting this up. I'm going to say you could probably just kind of feel this out. It doesn't have to be that exact. We just don't need it to be like insane. So this is pretty good. In fact, this is 10 units long. I'm going to make it a little bit less than 10 units long. I'm going to make it like here. Just in case. I just get this kind of paranoia, like the particles will reach the edge here, and they'll find some tiny little crack, and they'll like fall through the edge or something. I don't know. So just make it slightly smaller. The point is, we can't see the edge of it anyway. In camera, we certainly can't see the back here. And as for this up here, we can see the edge here, but really, you can see the collider geometry is here. So we really should never see the edge of the liquid. So that should be pretty good. Now when we press play, you know, it's the same thing essentially, but they get deleted when they go outside of the volume, which is fine. We're going to have the collider here take care of that in a minute. So that's cool. Now we have the particle separation and grid scale, as I started to say earlier. Copy, so right click and hold on particle separation here, copy parameter. Remember what this says, which is 0.1. And now I'm going to paste relative references to here. So right now it's 0, so it's erroring out. So let's just type in what we had a minute ago. Now this voxel size thing is not something that we're going to drive on here. What this is going to be whatever the particle separation is, which we just drove from here. So paste that there. And then multiply that. There's a little asterisk over there, if you can see it. Oh, let's just look at it in a second. Copy the grid scale here. So coming back over here, we want this to be the particle separation times the grid scale, which again is just going to be this times 2. So it's just going to be 0.2. Not a huge deal, but a lot of times when we're doing stuff in this lesson, you'll see it's going to be in terms of the voxel size of the simulation, and there just isn't a parameter to grab that from. So just as a bit of convenience, we can now refer to this parameter all the time, and it'll just be nice and easy. Cool.